Hi, everyone. Just wanted to take a minute to talk about some deductive reasoning, and we're also going to get briefly into the laws of syllogism and detachment, which are laws of logic that we can use to draw some appropriate conclusions. So, before, when we were dealing with inductive reasoning, that was when we were kind of looking at patterns and trying to predict what was going to happen, but we weren't necessarily proving things. Deductive reasoning, this is actually where we're now specifically only using what we're given and previously known facts to make a logical conclusion. So they're kind of similar in that you are trying to make a determination. However, deductive reasoning is not necessarily predicting. This one is more of you're taking exactly what we know to be true and then using what we know to be true to make further statements, right? So, for example, you're given that P implies Q is true and that Q is true. However, the problem is once we actually look at that information a little bit more closely, that does not inherently mean that the hypothesis is true, right? We have these two examples over here where we're saying that this is true and this is true, and then this is true and this is true. However, it could be either true or false, so we don't know yet. Now, if we were to look at this one, we're saying given the conditional and the hypothesis are true, could I determine what their conclusion would be? Well, we know if the conditional is true and the hypothesis is true, there's only one situation here, right? It's only this top one. Therefore, this must be true. And that first particular one, that's the law of detachment. So the law of detachment, that's a logical law stating if the conditional statement and the hypothesis are true, then the conclusion must also be true. All right. So if P implies Q and P are true, then Q is true, which you probably would have guessed. That seems like it kind of follows pretty well. So, for example, if Alicia scores 85 or greater on her test, she will earn an A in her final grade. So we're taking that first part to be true. And then we're saying Alicia scores 89 on her test. What could we logically conclude? Well, we've already stated that the conditional is true, right? I don't know why we would have lied about that. So yes, that's true. And then she scored greater than an 85 because 89 is greater than an 85. So therefore, by the law of attachment, we can conclude that she will get an A in her final as her final grade. All right. And that seems like a little bit more of a obvious situation here. But obviously you could apply these to more in-depth problems and kind of analyze a little bit more. All right, so let's try some more. If two angles are congruent, then the measures of the two angles are equivalent to each other, are equal to each other. Angle 1 is congruent to angle 2. All right. What can you logically conclude about the measures of them? So essentially what we're saying here is we have if P implies Q, that is true. So P implies Q, that is true. If we have two congruent angles, then their measure is equal. And we are being told that angle 1 is congruent to angle 2. So therefore, we have a true premise, right? So my P is true. Therefore, I can conclude that my Q is also true. So that essentially would mean that the measure of angle 1 is equal to the measure of angle 2 by the law of detachment, L of D. All right, if you finish the race in under 30 minutes and you win a prize, you finish the race in 26 minutes, what can you logically conclude? Right, you finish the race in 30 minutes, you win a prize, that is true. You finish in 26 minutes, 26 is less than 30, so that is true. Therefore, we can conclude that we won a prize by the law of detachment. Prize, yay, okay. Now, let's look at the next one. Next one's a little bit tougher just because we're not necessarily saying things about conclusions. Now we have the law of syllogism. That's just a logical law stating that given two true conditionals with the conclusion of the first being the hypothesis of the second, then there exists a third conditional where the hypothesis is the first and the second of the conclusion. Basically, this is the transitive property for conditionals, if for lack of better words, right? If P implies Q and Q implies R, then P implies R. All right, that's all we're saying. We're saying, A implies B, B implies C, A implies C. You've seen it before in just about every other situation for math, right? The transitive property, if A equals B and B equals C, then A equals C, so on and so forth. But it is a little tricky just to keep track of. So here we have a couple quick examples. assuming that the set of conditionals are true, what can conclude about the law of syllogism? If Kenji plays the trumpet, then he plays a brass instrument. If he plays a brass instrument, then he's a member of the marching band. So we have the first one. If he plays a trumpet, then he's plays a brass instrument. If he plays a brass instrument, then he's a marching band member. So we can use them and combine them. If he plays the trumpet, then he is a member of the marching band. That is truthful for this particular situation. All right, we could then also apply it in the world of geometry. If A, B, and C are collinear and B is between A and C, then A, B, and B, C are opposite rays. If B, A, and if ray, B, C, and I'm sorry, if ray, B, A, and ray, B, C are opposite rays, then A plus B equals AC. I'm sorry, AB plus BC equals AC. What can you conclude? What can you conclude? Again, essentially, we're just ignoring the orange part when we are rewriting this. If points A, B, and C are collinear and B is between A and C, then AB plus BC equals AC. So it's relatively straightforward. So let's look at the law of syllogism for these particular problems. If a number is divisible by 6, then it's divisible by 2. If a number is divisible by 2, then it is even. All right? So what can we conclude from that one? Well, we're assuming that these sets of conditionals are true. Therefore, we can say if an integer is divisible by 6, then even. That's it. That's all we're doing. If it is a holiday, then you don't go to school. If it is Labor Day, then it is a holiday. All right, can we conclude anything about this? So we're saying, again, remember the law of syllogism. If P implies Q, if Q implies R, so this is our P and this is our Q. Well, that's R, back to P, so I actually can't conclude anything on this one, right? Can I? No, we're not doing anything with it, right? We don't have anything in the correct form. Up here we had P, Q, Q, R, and that's really what we're looking for. We've just repeated P, and it's not even the same spot. However, if we were to rearrange this, you might see a little bit clearly, right? If it is Labor Day, then it is a holiday. If it is a holiday, then you don't go to school. So I could, if I rearranged it, see a little bit more clearly. So I do take back that you can't conclude anything. You can actually conclude something. You just have to rearrange it, right? Because we have both a P and a P here, and one is a hypothesis, and another is a conclusion. So we could rewrite it, and we could say, by the last syllogism, if Labor Day, then no school. So I apologize. I was looking at that quickly. But yes, ultimately, we can make a conclusion because we are able to rewrite this, right? So you do have to be careful. Make sure that if you have statements, you have one as a conclusion, one as a hypothesis, all right? So make sure you label them before you jump to conclusions. Because I just did it, and you realized exactly what could go wrong. So again, law of detachment. If P implies Q and P are true, Q is true. Law of syllogism. If P implies Q and Q implies R, then P implies R. All right. And that's everything you need to worry about for these. Let me know if you have any questions.